Hello. I can see you in chat. Everything's working. No technical difficulties today. Welcome. Today we're discussing clean architecture. So today is one of those days when I wanted to have a really short stream about a very, very specific topic, and then everybody, like 50 people showed up wanting to chime in. So I have a hard stop in exactly 55 minutes. So I've extended the starting time today. So there's a presentation coming, but I'll start it in about 25 minutes when everybody who didn't know that I've extended the time will show up. So I'm assuming halfway through the stream, I can show you some extra little tidbits, some tips and tricks, the meat of the discussion today. For now, I would love to open up with any kind of Q&A, any kind of questions you might have in chat. Everybody in chat, welcome. It's the first time that I opened the stream, and there's a few people here already chatting, and I love to see it. So thank you so much for showing up, for taking the time, for making the intention to show up and to contribute to this wonderful topic. Hello, Milan. Hello, Saddam. Hello, Eve. I believe it's pronounced, if I recall correctly. It's been a while. It's good to see you all. So today's topic is clean architecture. What do you want to know about clean architecture? I'm assuming you haven't read the book, because most people haven't. So if you have a question that is unintuitive, or where you try to adopt it and your teammates stopped you, everybody's enjoying the elevator music? Yeah. No, I mean, I have to admit, I used to do these streams manually with Zoom and then linking them up through YouTube and LinkedIn, and then having my own little sort of proxying going on. After I started using StreamYard, the most unexpected, low-hanging fruit, the most, never mind that I can easily set up the entire stream with just one single click. The feature I love unexpectedly is the elevator music and the countdown. So, hello, Tyler. Hey, it's good to see you again. It's on your shelf, but you haven't, but it's time to read it again. Milan, are we going to the tough questions? By the way, Milan and I had a podcast a while ago, and it was one of the first podcasts that I publicly discussed clean architecture. So thank you, Milan, and thank you for being here with us today. And also regarding updates on the Technologies podcast, there will be a podcast end of August regarding leadership specifically with Tyler. So thank you for being here, but I don't want to spoil it. We will discuss that when it comes. Question number 1: is the database really a detail? Okay. Well, we have a few people in chat and a few people in the audience. And hello, you people from the future. This is live, but not for you. You're from the future, so I'm from the past for you. But for me, you're from the future. Ken Beck calls this bitemporality. So let's think about that for a moment. Yes, thank you for linking it. For those of you on YouTube who are watching me talk to myself in chat, I am responding to LinkedIn messages, and I don't think they are being cross-posted. So I apologize. I do not have, the technology is not there yet. So I will read them out loud. And I can actually show them. Actually, Milan asked the question. Milan, where are you? Controversial. There we go. Is the database really a detail? So for those of you that have read the book, clean architecture focuses on this concept of the architecture is clean when it's focusing on your business intent, and you have abstracted away detail. So detail in a sort of lowercase d kind of meaning. There's a very vague, very wide meaning of the word detail. And hopefully put all of your detail into infrastructure and application layers. So Milan, if I understood you correctly, question being, which layer does the database really belong to? Before we get into detail, no pun intended, I'm sorry. I have two twins. We got, since the last time I did one of the big podcasts, I have two daughters now. I'm a dad of twins, and the dad jokes are just, I can't resist it. I'm sorry. So you've been warned. There will be cringe dad jokes. That's just who I am right now. Raul, thank you for the question. I will definitely get into that. Although it might be a little bit of a tangent, but we can. I'll have to discuss those things. Everybody here with the hard questions. I love it. Great audience today. Thank you all for coming, for showing up. I do actually want to share a little screen here. Let's do some screen sharing. Cinema layout. No, I want to present. This is one of the few applications that doesn't call screen sharing. Screen sharing, it's called presentations. Okay, so what I want to show you is the crafting tech teams. One of my old articles. This is the newsletter, by the way, that I started a while ago. I had a lot of fun writing it. But there's one specific one that I want to highlight. It's one of the first ones that was really popular. And it's about this. This is my preferred. You can see it, can you? God damn it, you can see it. I can see it. I'm sorry. Staring at that, not the window. Personally, I find this diagram to be my preferred way of describing it. The picture in the book has the use cases between the domain app and the application. But in the book itself, it's mentioned that use cases are cross-cutting concerns, and it uses the terminology, it is cross-cutting horizontally and vertically across the layers. So when I read that, I saw this in my head, and I very rarely see this described this way. Saddam, yes, this event is being recorded. In fact, after we are done, you will be able to watch the recording on YouTube and on LinkedIn. So if you have to go, that's fine. If you have a question, you can type it now and I'll answer it. I promise I will make the time to get around to it. So specifically, what I like about this diagram, I made this diagram. It's my little scribble. But what I like about this diagram is that it's very important that we highlight use cases always as business intent. So to answer Milan's question, where does the database belong? Is the database a domain concern? Is the database an application concern? Is the database an infrastructure detail? My answer to here is quite simple. I would prefer if we can always talk about the database implementation, the connection to the database. Thank you, Chopper. I would prefer if you could always refer to the database as an infrastructure level detail. Now, when is it not? That's the question, right? Because the database would not be a detail when you have really important compute going on inside a database. So Eve is coming from the world of event sourcing. And there it will be very natural to think about, okay, I have this event stream. That's my canonical representation. So it's completely okay for me to just consume an event stream and create a projection. And that projection will be, the model of the projection will be my domain level. And then the place where I store, so durably store on a hard drive or in a way that it's accessible, that will be my infrastructure layer. So that will be my database. But in an event sourcing perspective, it is very easy to do so because you can always just say that the schema of the database is always subservient to my schema of the projection, because my canonical source is always stored in the event store, in the event log. So I have no problem just dropping the entire database, changing the schema, and then just reprojecting it. All right, but that is a secret superpower of the event sourcing community, and that's not today's topic. In a more traditional application that I'm sure Milan is also coming from a very C# focused .NET world. So if you're asking me, does entity framework belong into the application layer, into the infrastructure layer, into the domain layer? My advice would be if you're building something really simple, then just put it anywhere and marry it with your use case. If you're building something really simple. And what do I mean by, and this is very controversial, because a lot of people say, no, it doesn't like create the interface and then the impl, I even have this here. It's this code example is from my article from yesterday. You have this, no, but I need the booking impl and the booking manager and the booking facade impl web port response manager booking. I hate this. I'm sorry, it drives me crazy when I see the impl, and I see that a lot from the hexagonal architecture community. The idea behind this kind of separation of not marrying your framework is that you have an interface, and I don't think the book captures it really well, is that you have an interface that captures the intent of the API, and the intent of the API, the interface, the port. So wait, there's now a more nuanced version of the driven port, so an incoming port, is in your domain layer. And then you're exposing that, and then in the infrastructure layer, you would have a specific MySQL entity framework booking repository, which implements the booking repository interface. So the actual concrete implementation would be in the infrastructure layer, and the interface is coming from the domain layer. A lot of beginners miss this. A lot of beginners think, okay, concrete class, where does the concrete class belong? Well, the book says domain, but everybody on YouTube says that if it's touching the database, it's infrastructure concern. It's that refactoring that usually is lacking. That separation of the actual intent from the concrete implementation. Now the problem is, there's more questions. Hang on. Yes. So Cosmin, is there any difference between a port and an adapter? I mean, with the terminology being used by the modern hexagonal architecture professionals, and I recommend that you look up Optivim and Valentina Zupac. And she has, I believe she's writing a book on it now. So if you check out her newsletter, you might be able to get a little bit more terminology. I'm not a big fan of hexagonal architecture, just to put it out there, because I don't like it. I have a feeling, like a gut feeling, that this idea of ports and adapters is creating a unnatural separation. I prefer using the idea of use cases, but I understand where it's coming from, because sometimes you do actually have a concrete class and it's implementing two interfaces, and then it's being injected 4 more items, and 2 of those constructor injected parameters are things that are coming in to serve the interface, and 2 of those constructor injected parameters are something that go out, right? So one of them is on the driven side, and 2 of them are on the driving side. But I find it very clumsy to generalize. So to answer your question, are there any difference between a port and an adapter? It depends. Usually they come in pairs. So a port on one side, there's an adapter on the other side that you're coupling to. But in the context of cohesion, you want to be able to tell which way the dependency graph goes, right? Usually you want the domain layer to terminate the dependency graph. So the domain layer is only cohesively coupled to itself. Your domain layer might have 3-4 domain contexts, or just aggregate roots, and you want them to be depending on each other, but nothing outside into the application layer, or God forbid into the infrastructure layer. That's what the use cases are for, from the diagram that was on the screen earlier. So this idea of ports and adapters, yes, it makes sense on the application layer. I wouldn't use ports and adapters internally on the, you know what I mean? Like if you're using ports and adapters to get between the layers, that makes perfect sense. But then on the terminating side, so on the infrastructure and on the domain, it doesn't make sense to go both directions, if that makes sense. Because if you go both directions, that means that you have a dependency through an interface that's being hidden through a concrete class, and it might not be clear who's driving. That's why I don't. That's why I sometimes find that kind of hexagonal architecture-esque dependency inversion to be difficult to follow, because it's violating the well, not always, but it often violates the single responsibility principle. And I'm aware. I'm sorry, audience, if this was all just a bunch of jibber jabber. Let's forget the hard questions. Let's simplify it down. Are we clear? Am I being confusing? Just let me know, and we can simplify it into more detail. Let's see. Should the main class encapsulate repository inside? Repository being interface inside a domain class. Let me think about that for a moment. Should the domain class encapsulate the repository inside? Should the repository being interface inside the main class? Now, I don't quite follow. This might be very specific to a very specific language. What I would emphasize is to be very, very, very wary of frameworks that use the terminology repository. When there's a framework that has a repository, it's usually not a repository. Right? So usually a repository class is encapsulating the logistics of managing a repository, but it's not a repository. A repository is something that speaks your domain language. A repository is not name of table repository. That's silly. That's not very useful. A useful repository is when I'm expressing specifically what kind of data is in the repository. Is an aggregate root, and it's very popular to name an aggregate root repository. I have topics on this. That's not what I want to show. This is not what I want to show you. I want to show you the repositories. Where's the repository? This one. I have an example here, right? So you want your repository ideally to emphasize the data specifics of a repository. Specifically, emphasize that, yeah, this repository has users, but this one only has the admin users, and this one only has these users from this region. Maybe your aggregates are actually partitioned naturally through some very, maybe you have multiple vendors or multiple brick and mortar shops, and then you have a repository for each shop. It would be very natural to have a repository for each physical location, and then have a repository only returning aggregate roots from that location. The same way that there is a certain locality, let's say, to a restaurant, where you might have tickets for open tables on what needs to be cooked in the kitchen. And if you have a system for that, then the entities inside the database have locality. There are consequences of me serving one table over the other that overall, if I'm comparing two restaurants with each other, I wouldn't have. Unless one restaurant is like delivering food to the other restaurant, then it might make sense. But there are these sort of locality-oriented natural boundaries to repositories. So your repository should express the nature of how the aggregates inside the nature of the repository are partitioned. Not so much what database table they map to, right? So if you have like if you have an account that is going into the accounts table, and you have an account repository, you didn't do much. And in this example that's on screen, it's speaking of this idea of, oh no, I have a very specific part of the accounts that are rental accounts, and I want to get a rental account for a specific user, because not all users have rental accounts. And when I'm asking for this concept, I'm expecting 1 or 0 rental accounts for this specific user. based on, let's say, some partition, or in this case, all rental accounts or all accounts of type rental. But in the database, it might map differently. You might have all the accounts and then you have a rental table, and you might split them that way. Again, I don't want to get into this whole polymorphism idea of maybe one table has different classes of accounts type and then they map. Usually this doesn't work out very well, but it does work out very well when you're partitioning. It doesn't work out very well when you're doing polymorphism with SQL tables, and they have these subtables and inheritance. I hate that kind of sort of ORM led square extends rectangle, and then it goes into this weird detail. Sandy, if that was the meat of your question, please let me know. I'll go on to the next one, but if you want to continue the discussion, happy to respond in chat. I'm just trying to make sure that I am actually receiving the chat in as I'm supposed to. Indeed, I am. Okay, Sandy, yes, repository meant infrastructure class. A data access object. Okay, so a data access object, that is a very good level of detail. I wouldn't say that repository is meant for data access, right? Like the repository is meant to bridge what it's a weird conversation, because repositories are a domain-driven design concept, not so much clean architecture. I think this is a very common overlap in the C# community, because the latest iterations of the sort of default frameworks for those environments that are heavily being pushed by Microsoft, they are sort of DDD, CQRS, and clean architecture focused, but I wouldn't say they serve them earnestly. And this is also mentioned in the book, which is a very important detail, that you shouldn't marry your framework. The framework, whatever framework you're using, whatever frameworks you're using, whether that's just a application framework, network framework, ORM framework, some kind of conversion framework, maybe data access layer framework, maybe you're using some kind of event sourcing framework or projection framework. You shouldn't marry the frameworks, because the frameworks are, in the same way that the event sourcing community is emphasizing this idea that keep the canonical source raw and then create projections, the same way you would want your domain logic to be free of any framework detail, and then you would choose which framework you're using as a library, which framework you're using for which kind of concern. And I get a lot of pushback on this from the React community when I talk about clean architecture on the front end, because they love marrying the framework, right? It's this idea that the framework is so powerful that I'm just going to do everything the framework tells me. But the framework does not have your best interest in mind, because the framework was not created. There's no incentive for the framework author to optimize the framework for your business. The framework is being optimized for adoption, so as many people as possible use it, which means that it is very generic and it is not a good fit on a broad spectrum. The more popular it is, the less of a fit it becomes for a very specific niche application. That's the idea behind clean architecture. That you shouldn't, when your architecture becomes so specific and so well adapted to your business, that at that level, the database, the frameworks you're using, the libraries you're using, they become a detail. And you shouldn't be subservient to them. Instead, you should be using them as tools. Nick Shumeko mentioned a very good point on this about clean architecture in an enterprise level React application, where Moment.js it reached end of life and they had to sort of abandon it, and there were API breaks, and they decided to just replace all of it. But they were very tightly coupled to Moment.js. Especially, it's the kind of framework where you have this sort of global factory function that also acts as a facade. So you do Moment constructor or Moment function for everything. And then, every little toolbox, every little interface, every little text box that has a date or any kind of text that represents a date, it just becomes, you just become married to this framework. And then if they start supporting it, the business gives up the impression that, oh, we need to shut down the business because moment is no longer available. It's no longer it's no longer considered good practice, or it was abandoned, or the support is not where it used to be. But that's not the case. When that happens, you will change it. And oftentimes, teams make the mistake of just marrying plan B. Just you divorce from this framework and you marry the other one. And Nick had a great use case that he presented on a LinkedIn audio event about how, for example, Sandeep's example is repositories as interfaces for DAO. It's the same thing here. But if you find that you ever had to change the framework, as you're changing the framework, please create an abstraction around it. I fully empathize and agree with everybody in the community, especially the haters of clean architecture, that it is completely silly to assume that we need an abstraction for the database because we will change it, because we will go from Postgres to MySQL. I have never seen, of 1,000 companies, I've spoken to so many developers now, that among 1,000 companies, maybe 10 of them had done that, and maybe 5 of them really needed to. But those 10 should develop a abstraction around their database because they have shown evidence of requiring this strategy. But unless your business has shown evidence, don't bother. However, there's another take, and it's in this article that I wrote. And specifically on the contrarian side, abstractions on the repository, so to sort of have a DAO class separate from, so you have a repository which is in the domain, and then you separate it from the repository which is in the infrastructure. When you're in the type of business, in the type of industry, where you require a very strict guarantee that no matter what happens to the database, how the code evolves, we will always be able to run very fast tests with very high coverage in a very low amount of time without having to replicate the database. If you're in an industry that requires database tests, and because you have complex compute on the code side, so in PHP, in Node.js, in C#, you're doing compute on the code side, then please abstract your database away, not because you changed the database, but because you want to switch the database for your tests, because you'll have a lot of tests. And if you'll have 10 or hundreds of projections that are reading something from the database and creating something and computing something in your language, in your coding language, then you want those tests to run really fast. If you have to go to the database to get that test, even if it's just an H2 database or SQLite, it might already be clumsy if you're not abstracting it properly. So that's one element of this. Thank you, Sandeep. If I missed anything, please just let's keep the conversation going. Is there any? Yeah, we did that. Okay, Tyler. Sometimes we confuse database with the data, or we confuse business stakeholders when we use those terms interchangeably. Yes, I've seen this a lot, specifically when. So clean architecture, we want to essentially talk about the intent of our business. And sometimes the intent of our business is that I have customers, but I don't care how the customers are stored in the database. So I will need to create a user, but maybe I'll use, AWS's user IAM, identity management system, right? So I will just copy whatever they have for schema purposes, and then adapt to that, and then maybe project and change when I import it into my data warehouse or CRM program. I will adapt it. I will just create an ETL, or just have a projection. If I'm event sourcing from that perspective. So I will, no problem, become a what is it called in context mapping? I will become a downstream collaborator. I will adapt myself to whatever they're doing. They say it's in this schema. Sure, it's in this schema, because the business might not even requested the schema to be concrete. They just wanted to have commoditized user management. They don't care how it's done. But for something that's really for the part of the business where you care about the data, not just the schema of data, but the data points themselves, right? So maybe you have, for example, if you're training some kind of AI, or if you're doing LangChain or any kind of machine learning, then you not only care about the schema, about how the data is structured, but particularly how the rows are created. And you notice this a lot in businesses where if you run your tests are not realistic, where you need to run your tests in production because there's something about the data that makes your code run differently. If you're in such an industry, if you're in such a business, if your context is to create such systems, then definitely inspect in the under the guise of clean architecture, inspect whether your database contains compute. If your database contains important compute, important business invariants, if it has stored procedures, then yes, it's part of your domain, right? So if your data is surrounded with compute, it's an object. So your database will become a completely autonomous environment, and that will be a domain that will encapsulate an entire application, essentially. And then you connect to that application by having exposed sockets or connections, or it might even have specific tunnels or materialized views. And then the materialized view is the infrastructure or the application layer to that particular domain. Machine learning models are of that nature, and we gotta admit here that software engineers do have a much better CI/CD and sort of tooling understanding when it comes to craftsmanship and automation compared to data scientists or AI scientists or data engineers. But data engineers have much better intuition on how to model data and data schemas correctly. And we see this a lot, especially when we had a conversation recently with Eve and on the event sourcing community about, if you're struggling with coming up with aggregates, with clean aggregates with short streams, identify the code smells in your database. Your database might also have code smells. And if there's code smells in your database, like having a lot of surrogate primary keys, or having some weird synthetic data in there that's denormalized for no purpose other than serving some kind of infrastructure concern, or having like columns in there like deleted at and status and hard delete yes no, those things that your ORM might create, then you don't need to question whether that's actually still serving your domain. Once you get into that level of coupling, I'd say that's no longer your object model. That's actually just a storage mechanism. So it's an infrastructure concern, and then it becomes separate from your domain. Whereas for AI and machine learning, the domain itself might be inside a database, and the materialized view might be an application or even infrastructure level concern when looked from the outside. So to echo back on Cosmin's question, is there a difference between port and adapter? Sometimes we see the inverse relationship from a database, especially when it comes to newer concepts like machine learning. But I haven't explored machine learning in the context of clean architecture a lot, but this might be a very interesting topic to cover on some other episode. Now, let's go to the other questions. We have 20 more minutes. For those who are joining us on time, so without being aware that I moved the time 30 minutes early, welcome. There's a little presentation in the background that highlights a little bit of context on clean architecture. Before I go into a lot more detail on what's going on, I just want to take a little break. We're answering questions from chat, and this is the part that I want to talk about while I read the remaining questions. Okay, what application can we classify as simple, Saddam? That's a very good question. This is in the context, I believe, when I said earlier that, it's don't complicate the clean architecture if your application is simple. It may be that the business intent around the application, so the interface, let's say, if I'm talking about the interface of the domain, just to describe the intent of a piece of code or a module or a microservice, it is very possible that for an MVP, the intent of the system is not to describe the system, but that the intent of the system is for it to be cheap and simple. Right? So when you're building an MVP, when you're building an MVP for Uber, your intent is not to capture Uber, the business. Your intent is to capture cheap. And then you have something cheap, and with that cheap thing, you are serving the idea of, can we validate this idea of creating the Uber application? Right? So the domain becomes, is it still cheap? I'm doing a cheap test. This idea that I'm doing a cheap test, that is the domain. And it is very likely that in such an application, the entire layer structure is inside out. I just have some cheap protocols. I just have cheap frameworks all tightly coupled together. And then the idea of what pictures and what fake screenshots and what fake data makes it out into the application, that is a configuration and sort of static detail. Right? So we have to talk about what the intent is. Sometimes the business intent is not to build something for the business. Sometimes the business intent is to build something cheap. But then when you're migrating from something cheap to something that has to be very business focused, then you need to invert all the layers. And that's very hard. And that's how most projects go. And that's why clean architecture is really hard. Because I can tell you what the ideal folder structure is and what the ideal project setup is. But that will be coming from the wrong side. That will come from the clean side. But the clean version of the product might not have proof of market demand. You might need to build something cheap first to prove market demand, and then convert that ugly thing that is not following clean architecture into something that is. Right? So I wrote this quote in the article that I'm presenting on the main screen, which is, clean architecture is an enterprise-level object-oriented programming using solid principles applied to systems design. Right? So clean architecture is enterprise-level OO programming using solid principles applied to systems design. So it's this idea that clean architecture isn't how you should structure a perfect project from the beginning. Clean architecture is what you get when you take a market-validated, proven, valuable, profitable piece of code that is completely written like a bunch of turd and everybody hates it, and then you refactor it using the principles. And then the output of that refactoring is something that follows clean architecture. But it's very rare that you would normally, as an engineer, say, oh, I need to do a clean architecture project. I'm doing a clean architecture project. How should I structure the folders? It's like, no, you're not doing a clean architecture project. You're building something cheap to prove that the business should invest more money into building this feature. And the intent is cheap. And then later on, when it's validated, the intent is scale. And then when it's validated, the intent is scaling the teams. And then the architecture kicks in. Okay, so now we went from cheap to scale to scaling the developers. Oh, now I need to refactor it. Right? But you refactor it to serve your current needs, not speculative needs that you might have in the future. Right? So those criticisms of, oh, maybe I'll change the database at some point, that's speculative. Even in clean code, even in refactoring, even in sane, sort of well-mannered, benevolent craftsmanship patterns, we never refactor for speculative needs. We always refactor for what's in front of us right now. Things that we have evidence of needing. Even if there's a feature branch that will be merged next week, not even for that. That person who's merging that branch, that person can refactor it. This is what TDD shows us. TDD shows us that The moment I start speculating and I start creating abstractions for things I don't need yet, but I think I might, that's an endless rabbit hole that you get lost in. And then if you don't know how to get back and you don't have tests, it's a huge waste of time and you lose context. And you're doing this equivalent of, in 15 minutes, I have a speed reading cohort, and the same thing is happening in speed reading. You read a line in the book, but your eyes are mechanically not following in a straight line. They are jumping. So every now and then, when I start daydreaming and I'm bored with what I'm reading, my eyes might jump back. It's like, oh, did I read this already? Did I miss something important? And this is what happens with developers in architecture. If the architecture is not clear and the folders are all over the place, you might read something and change something, and you're like, wait, did I forget something? Did I change it there as well? And that's a sign that maybe, if you ask yourself, maybe reading it is not clear enough and you should refactor it. Not for what might come in the future, but right now, for the fact that you just had to question yourself. You did a pull request to change something very minor, and you had to do shotgun surgery. You had to change 12 different files to do a minor change. That should immediately show you that there is already an opportunity to clean up the architecture by refactoring what's not working for you, what's slowing you down. Great question. Let's see. Jorai, I'd rather just expose what I need from the framework as functions. Yes, I like this as well. I like even if I'm using ORMs, or if I'm coaching a team that's using ORMs, I always told them, yes, you don't have to extend a subclass, a abstract class from the ORM to use the ORM's features. You can just annotate it, but the annotations also make it, coupled. And I prefer, if I have to use an ORM, I prefer to capture it in, for example, into a repository implementation, so the concrete class, and then I'm using it there as a facade to hide that I'm using the framework, and then I'm using the entities, without annotations. I hate having annotations in my entities, just because it introduces this concept of magic, and then it's all fine and well as long as it works, but then when it doesn't work, you don't know how to debug the magic. And if your domain entities are not working, you want to debug the domain entities. If your ORM is not working because you've configured it incorrectly, that's an infrastructure problem that I would ideally want to solve only on the infrastructure level without thinking about my entities. So whenever magic, annotations, what is it? PHP has it now. It's attributes. And we had, PHP doc, and GS doc is also very similar in that vein. And TypeScript has its own sort of decorators kind of idea, but it's still just computed JavaScript. So I wouldn't go into too much detail on that. But I want to reiterate, that quality is usually the output of refactoring, of iteration. This is the whole idea of Agile. Agile says that quality, that speeding up the team is the output of iterating on the team. Increasing the quality of the project, increasing market fit for the project is the activity of iterating on the product, and increasing the code quality is an output of refactoring and iterating on the code smells that are there, right? So you take the shitty stuff that's there and you refactor it, and that's what produces quality while also reducing tech debt. So it's a win-win. But if you don't take the time to do this, you'll never get there. And you can't start from the clean state and remain clean, because you need to, if you're cooking, I clean the kitchen, and then I cook, and then everything's a mess, and then I clean it back up. But while I'm cooking, I am cleaning as I'm cooking, because I don't want to sit down and eat and have a messy kitchen. So as much as I can, I already clean. I have this sort of poka-yoke sort of meets French kitchen sort of vibe going on in the kitchen, where I just prepare everything I need in specific bowls, and I have everything at hand. And when I have everything in hand, then every time I use something, it completely empties the bowl, and then I just clean the bowl, right? So there's this idea of I'm constantly refactoring my state as I'm producing something. This is the idea behind test-driven development. This is the idea behind Agile. This is the idea behind, well, not behind Scrum, but it is the idea behind clean code and the whole craftsmanship movement. And it is the idea behind clean architecture, in that when you're complexity of the business intent increases, that's when you start cleaning it up. Because until you have a really complex business problem, you don't have any mess. So if you start with clean architecture, the level of complexity for building clean architecture is this, and the level of complexity to build your simple application is this. And it will not be worth the time investment, but it will be fun for you to learn. But maybe it's unfair that you're being paid to do that. We have, and I love this conversation. What did we not answer? So I think there's a conversation going on between Tyler and Raul. So Tyler, is the repository an abstraction between your data and the detail that is your database? Is it the place where you injected infrastructure detail, which can be easily replaced when you decide to stop paying for SQL Server license? That's a good question. I'm not that particular about the implementations of like which SQL flavor we're using. I love, when I'm using Postgres, I will use Postgres terminology in my repositories. I hate having this idea that I need to use standard SQL so that I can change SQL flavors. I don't think that's practical. I would rather, on the infrastructure layer, couple it to the type of database that I'm using, and then if I have to change it, I will create a new repository for it, a new repository implementation for it. But the aggregates, the data models might not stop at the repository. You might run into something that is more NoSQL driven or maybe even event sourced, and then you don't even have a concept of having a very strict schema. Your events will have schemas, but you will have to express, well, here's my object that I want reduced. Here's the output that I want to project and make available on GraphQL, and that will change all the time. So every time it changes, I will drop the database and recreate it. Right? So for that kind of use case, it doesn't matter to me what SQL I'm using, as long as there's a common abstraction for create table, drop table, add column, remove column, and sort of basic data type mapping, if that makes sense. So the question is, repository an abstraction between your data and the detail is your database? I would say the detail is the fact that the detail in most cases is the fact that you have objects in memory, and when the application shuts down, the memory isn't lost, but instead goes somewhere onto disk. But it's not the server that does this, because that might be the perfect abstraction. I keep everything in memory, and then the server itself is storing what it has in memory. Like the way when you hibernate your computer, what you have in memory is just do a quick snapshot, and then you can hibernate your computer, and it goes onto disk. And then when you open it, the memory is still there. That would be a perfect abstraction for an ORM. But that's not usually how it goes. Usually, you have to control sort of, because it's complex, because the data is non-trivial, and it might be sharded differently than your memory is sharded. So what might happen is you might want to shut down the server, but the act of moving the memory back to the disk space, to the hard drive, is an application level concern, because it might have that level of complexity. Or maybe the database is not on a local file, like with SQLite or with DuckDB, as is the node of the server, but there are hundreds of compute nodes that have memory and one centralized server, or maybe two centralized servers. So this idea that I have 100 nodes that have memory, that have objects in memory, when they shut down, they need to go to two different servers onto their disk. So the communication of how I transfer my memory over to that server, that is what we're abstracting. We're abstracting this transport mechanism of moving performance and then essentially hibernating it with durability in mind, with storage in mind. I think that would be the best level of detail. Because if you ask me, the data, well, the data is only really useful when it reaches the user. So when you're doing analytics, it's the data projection, it's the DTO that you care about. When you're querying a database for analytics, it's the query results you care about. When you're querying some application, it's the state of the application that you care about. The data itself is very rare for anybody on a complex business to be exposed to clean architecture, data architecture in such a way that you would just open up phpMyAdmin and then just have a normal relationship with the data. I think those times are over. And nowadays, data lakes and data warehouses and things like Snowflake and Aurora are taking a more data mesh, data lake sort of approach to reading data so that it can be externalized on a third-party dashboard or the third-party analytics application, or maybe fed into some cloud-based machine learning thing, and then used by end users and B2B users or internal analytics? That's a very good question. We have a repository concept for DDD, and we have a repository for the tools themselves. Yes, so this now touches on this idea that, yes, DDD uses the word repository, but there are also frameworks that use the word repository for handling the logistics of how a repository stores data on disk. And I hate that it's the same word, because really it's the repository for your domain concept. So if you're doing bookings, you have a repository for some aggregate in there. But the repository that your framework gives you, that is just a storage mechanism. That is not the actual repository in the domain terminology. But these are really hard. It's a sort of chicken egg problem of who came up with the word and why can't we come up with better words. But that's something to watch out for if you're using a framework. Doctrine does this a lot in PHP. I hate the entity repository, but they're not. The entities are not entities. The repositories are not repositories. They're just infrastructure concerns, tools to synchronize data. They're just a data mapper. It's not really an ORM, but it's hard. Yes, Tyler, and this is a cool concept. The complex can only be addressed with the simple. I like this, because this is ideally what happens during refactoring. You have an infrastructure level where the infrastructure is tightly coupled to the domain when you are in the phase of the business where you are doing something simple, when you were doing something cheap, when you're doing something to convert. And then the infrastructure concern became so complicated, you needed to, do deployments without downtime, or doing database sharding, or having high uptime, or having a separate read and a separate write side. And it may become so complex that you say, okay, in order, it's now married together and tightly coupled to all levels of detail. In order for me to simplify this complexity, I need to divorce this by inverting the dependencies, create interfaces, put the implementation side into the infrastructure layer, and simplify it away from domain concepts, right? So that's the idea of why you have a domain layer, because you're extracting infrastructure from it and you're cleaning off. You make your infrastructure, your database, not know about the domain anymore, and then you give that infrastructure level concern to a platform team. That's the whole idea behind clean architecture, is that you can constantly polish, okay, this is a domain concern, this is a domain concern, this is the domain concern, and then you keep peeling off pieces as the complexity of the domain increases, so that you say, okay, I don't want the caching layer to be part of my domain. I don't want the database layer to be part of my domain. I don't want the database sticky session routing thing to be part of my domain. I don't want my DTOs to be part of my domain. I don't want my authentication cross-cutting concerns to be part of my domain. I don't want the prefixes for what my logging elk stack thing is using to be part of my domain. And then you slowly pull, if you start with a domain coupled system, you slowly peel those things out of the domain, making the domain highly cohesive with itself, while everything else is being stripped of domain concerns. That is the proper way of building this. You refactor it out of a big ball of mud. And that's okay to do so. And it's okay to be on that level of we will start cheap by creating a sort of modular monolith, or even just a big ball of mud monolith. And then once the complexity grows to the level that it's valuable to the business and we have market demand, then I will refactor it to the needs of that business intent, so that the architecture will match the level of, let's say, technical excellence the business requires. Sandy, this will have to be the last question, because we need to wrap up. I love this. I love this live stream today, but I do want to keep it to under an hour to not get carried away. I will remove the screen share, and now you can see my face. If for a feature we create a vertical slice presentation server domain repository, then how do we plan reusability? Say a domain class needs to be used in multiple features, or say any repo class. For example, we may have two use cases needing account object how should we plan for usability? And I think this ties in well with the question that we got earlier, this idea of CQRS versus application services. To wrap up on this, I would say the best level of intent that I can share with you is that it's completely normal. It's completely normal for you to have use cases that depend on each other. You might have an account object that has a use case, and you might have an account object, a use case for creating an account, and then you have an account for closing and a use case for closing an account, and then you have use cases for what the owner of the account is doing with the account. I think that's completely fine. That is also completely normal for a multi-vector marketplace, for example, an advertising network that has publishers and advertisers, or people who have spaces and people who have ads. There will be overlaps, and the complexity is usually in the overlap. I wouldn't say you should reuse the use case per se. The use case should be specific. I would encourage you, though, that once your domain classes start growing, when the number of use cases expand, it's probably time to split the domain objects. So I wouldn't say a domain class needs to be used in multiple features, but ask yourself, as you're gradually introducing those features, is it still the domain class? Or do these 3 features use this part of the domain class, and those 2 features that other part of the domain class? When that happens, you should be able to remodel that class and split it. Clean architecture and domain-driven design is not about creating the perfect system on day one. It's about continually refactoring it to adapt the domain models and the underlying storage mechanisms to the continued business needs. So if you had 10 features last year and today you have 30 features, it's completely plausible that you have to redo all of your domain classes. I don't see this happening enough in modern organizations, especially in startups. Like if you created 10 repositories and 40 entities, and you had 10 features, and now you have 40 features, I don't want to see those original entities there anymore, because they're probably no longer relevant. And if they are still there, they're probably just a huge mess with different responsibilities, violating the single responsibility principle, very likely. And if you're not using vertical slice architecture, you will notice that you can't simply cut them off and slice them away. Wow, this was great. Great stream. Didn't expect this to be so action-packed. And we got through all the questions. So with that, I would like to wrap up. Thank you all for coming. I believe we did address all of the... Oh, we actually had a lot of questions that didn't make it into my live stream. Okay. Okay. Yeah. Jarai, I'm sorry, I missed some of your messages. It didn't reach my streaming software fast enough. Wow, this is really cool. Okay. Thank you all for showing up. We will continue next week. This is a weekly thing. Same time, same place. We can follow up on clean architecture and choose another topic. If you want to linger about in chat and talk to each other, I would very much invite you to that. I will leave the broadcast on for a little while longer, but I do have to jump off to another call. Thank you all for showing up today. See you next week, and have a good day.